Hello everyone. Today we are going to solve example 2.1. That's the first example for this chapter. What is given is blue and yellow streams of paint, each having a density of 850 kilograms per cubic meter, enter a pipe with an average velocity of 1.2 meters per second as shown in figure. Would you expect the paint to exit the pipe system as green paint or separate streams of blue and yellow paint? Now, the givens are the density and the average velocity. In the figure, you can see the diameter given as 5 centimeters, and the kinematic viscosity for part A is given as 1 Pascal seconds, and for part B, it is turned to 0.01 Pascal second. Now, initially, we are going to solve for part A, where the dynamic viscosity is 1 Pascal second. Now, what does the question ask? Now, here we have yellow paint, here we have blue paint. They are entering to the pipeline, and now we are asking is, after a certain length, will we going to end up with having a green paint where there will be, of course, mixing of yellow and blue paints, or will these yellow and blue paints will continue to flow as separate layers from each other? So to answer this question, whether they will have separate flows or they will mix with each other such that we are going to end up with green paint, the answer lies under the condition that whether you have a laminar state of flow or you have a turbulent state of flow. And now we know the answer. We can find the answer simply by checking the state of flow by looking at the Reynolds number. So I'm going to just make a new share at this point such that you can see the solution procedure. Just a second. Okay, now we are dealing with example 2.1. If I simply write the given ones, just this, and velocity is 1.2 meters per second, diameters is 5 centimeters. That is the given values to us. And now what we know is for the calculation of state of flow, we have to calculate the Reynolds number, which is simply velocity times the diameter divided by kinematic viscosity. Now, in this problem, kinematic viscosity is not provided, but we had been given the dynamic viscosity of the liquid. So what I can do is I can just express this kinematic viscosity by making use of dynamic viscosity divided by density. So if you do write Reynolds equation again, density, velocity, diameter divided by dynamic viscosity. So at this point, we know the Reynolds number. So all I need to do is to calculate the Reynolds number with the given values. Now for part A, dynamic viscosity is given as 1 Pascal second. So if this is the condition, let's put everything in the Reynolds expression. Density is 850 times velocity is 1.2 times diameter is 5 centimeter. So please be careful to make the conversion to meters. It's a very common mistake. Divided by dynamic viscosity, which is given as 1. So from here, if you solve for the Reynolds number, what we obtain is 51, which is less than 2000. That will give me laminar flow. So if it is laminar flow, what happens? I know that there will not be any mixing. The layers will flow on top of each other, and those blue and yellow paints will not mix to each other. So at the end of that pipe flow, we are going to observe just blue and yellow paints separately. Now, what happens if you have for part B, where you have your dynamic viscosity 10 to 0.01 Pascal second? Now, in this situation, I will calculate the Reynolds number again, 850 times 1.2 times 5 10 to the minus 2 meters, and divide it by 0.01, and the Reynolds number becomes 5,151. So this is greater than 4,000. So we have turbulent flow, meaning there will be mixing. Hence, we are going to have a green paint flowing in the pipeline. So we can go back to our problem. Hence, you had been given the solution here. Similarly, as you see, the Reynolds number becomes less than 2,000. Hence, we name it as laminar flow. So the paint will exist as separate streams of blue and yellow, because laminar flow, as we had just discussed, is well-ordered, stable state of flow, and there is no mixing. So that is the visual that we are going to see. What if we have dynamic viscosity of 0.01 Pascal second? So the Reynolds number becomes greater than 4,000. We have turbulent flow. Hence, due to that fluctuations of the velocity that we had discussed before, the paints will mix to each other and it will exit as green stream. I think this is clear.